All right, welcome. Today, we are jumping right into the world of Python. And we're not just going to talk about it, we're going to build a program from scratch. So let's get right to it.
Have you ever just wished you could tell a computer exactly what you want it to do and it would just listen? Well, that's literally what programming is. It's how you learn to speak the computer's language.
And our goal for today is pretty straightforward. By the time we're done here, you're going to have all the essential tools you need to build your very first simple program. We're talking about a program that can actually ask a question, remember the answer, and then make a decision based on it. So let's start with the basics.
First up, we need to look at the absolute fundamentals, right? These are the building blocks for pretty much any program you'll ever write.
Okay, the single most important concept to get your head around is the variable. The easiest way to think about it is like a labeled box. That's it. It's a box you can put some information into, and whenever you need that info later, you just call out the box's name.
So, for example, if we want to store someone's name, we could grab one of our imaginary boxes, stick a label on it that says name, and then put the actual name, say Tom, inside. In Python, the code for that looks just like this. That single equal sign is called the assignment operator. It's basically you telling the computer, hey, see this thing on the right? Put it in the box on the left.
Next up is something called sequence. Now this sounds all technical, but it's really not. It's just like following a recipe. A computer reads your code from the top to the bottom, one line at a time, one instruction after another, in that exact order.
Now those boxes are variables. They need to know what kind of information they're holding. We call these data types. As you can see here, we've got a few main ones. Integers are just whole numbers, like 23. Floats are numbers that have a decimal point, like 3.14. Then you have strings, which is just a fancy word for text. And notice how hello is in quotes? That's super important. It's how Python knows it's looking at text. And finally, you have booleans, which are just true or false. That's it. Getting these types down is absolutely crucial.
Okay, so now we know how to store information. But a program that just keeps all that information to itself, not very useful, right? So how do we actually get it to communicate with us?
To make our program talk to us, we use the print command. It's super simple. Whatever you put inside those parentheses, that's what gets shown on the screen. It's the classic first step for every programmer, making your program say, "Hello World."
And to let us talk back to the program, we use input. This command does two things. It shows a prompt on the screen, like enter your name, and then it just waits. Whatever you type in, it gets stored in a variable. In this case, it goes into that name box we talked about earlier.
Now, here is a classic trap for new programmers. Let's say you ask the user to enter a number and they type in the digits 10. What kind of data do you think the program saves? An integer, right? It's got to be a number, yeah?
Nope, and this is a huge aha moment. You got to burn this into your brain. The input command always gives you back a string. Always. So even though the user typed what looks like the number 10, the computer sees it as text, the character 1 followed by the character 0. And you can't do math with text. This is a really critical distinction.
So, how do we fix it? We use a little trick called typecasting. Take a look here. On the left, if you just use input, you get the text 10, and trying to do math with it will just crash your program. But on the right, we do something clever. We wrap our input inside another command, int. This tells Python, hey, whatever text you get from the user, I need you to convert it into an integer, a whole number. And just like that, you have a real number you can actually use in calculations.
All right, our program can now store data and have a conversation with the user. Now for the really fun part, teaching it how to think for itself and make decisions. We do this using something called selection. The best way to picture it is a fork in the road for your code. Based on some condition, the program will choose to go down one path or another. And the keywords you use for this are if, elif, which is just short for else if, and else.
Let's look at a quick example. Here, the program uses what's called a comparison operator, that greater than or equal to symbol, to check a condition. It asks, is the score 50 or higher? If the answer is yes, if that's true, it follows the indented code and prints pass. If it's false, it skips that and goes down to the else path and prints fail. See? It's making a choice.
So, what if we want our program to do something over and over and over again? Well, that's where iteration comes in. We usually just call them loops. This is what makes computers so incredibly powerful. They can do the same boring, repetitive task millions of times and never get tired or make a mistake.
In Python, you've basically got two main flavors of loops.
On the left, there's the for loop. The code for I in range 3 is just a simple way of telling Python, I want you to repeat this block of code exactly 3 times. It's perfect for when you know ahead of time how many repetitions you need. On the right, we have the while loop. This one is different. It keeps going and going as long as its condition is true. In this case, it runs as long as the variable I is less than 3. This is what you use when you don't know how many repeats you'll need, you just know the condition that should make it stop.
Now, before we put this all together, we have to talk about grammar. I know. But just like English, Python has rules, and if you get them wrong, your program just won't work. So let's quickly cover the most important ones to save you some headaches. Let's quickly break these down because they are so important. First, indentation. In Python, that space at the beginning of the line isn't just for looks, it's literally how Python knows which lines of code belong to an if statement or a loop. It's not optional. Second, you always need a colon at the end of a line that starts a new block, like if, for, or while. Third, use the right keywords. Python knows elif, it doesn't know else if. And finally, always remember to wrap your text in quotes to make it a string. Getting these 4 things right will save you so much frustration. Trust me. Okay, the moment of truth. We've learned about variables, talking to the user, making decisions, and repeating things. So let's trace a complete program and see how all of these pieces work together.
So here it is, our little program. All it does is ask the user for a temperature, and then based on that number, it decides what message to print. As you look at it, see if you can spot the things we just talked about. We're getting input, we're converting its type, and we're making a selection.
Let's trace this exactly how the computer would. Step 1, it hits the first line, asks for the temperature, and immediately converts the user's answer into an integer. Step 2, it does the first check. Is the temperature 30 or higher? If the answer is yes, it prints too hot, and then it's done. The rest of the code is skipped, but if it's not, it moves on. Step 3, it performs the second check. Is the temperature less than 15? If that's true, it prints too cold and stops. And finally, step 4, if it got past the first 2 checks, that means the temperature wasn't too hot and it wasn't too cold, so it has no other choice but to take the final else path and print nice.
And that brings us to our final challenge for you. Based on the logic we just walked through, what is the exact range of temperatures that will make this program print out nice? Take a second and really think about it, because being able to answer that question, understanding the precise conditions that lead to every possible outcome, that's the core of computational thinking. Thanks for joining me.